This section is about discontinuities in a graph. So a discontinuity is when you're drawing a graph and you can't keep your pencil on the paper. So I remember it as POP, pencil on paper. So a discontinuity can be in the form of an asymptote. So if your graph is like this, and you're tracing your function, all of a sudden from left to right you have to jump over, your pencil has left the paper. Another discontinuity would be in the shape of what we call a hole. So when you're tracing it, you have to jump over the hole, so your pencil has left the paper, so your pencil's not on the paper. So a discontinuity can be an asymptote or a hole. So to find a hole, it's literally a hole in the function, it's an open circle. What you need to do is you're going to look for having a common factor on the top and on the bottom. And holes always take precedence over vertical asymptotes. So first you check for holes and then you check for vertical asymptote. So to do that, what you need to do is factor. So I can't factor out the top, so this function factors into x plus 1 times x plus 1. So there's not a hole because there's not x plus 1 and x plus 1 on the top and the bottom. So then I'm going to find the vertical asymptote. So what you do is you set the denominator equal to 0. So x equals -1 is the vertical asymptote. Number 2, you need to factor. So I can factor out the top to be x minus 2, x plus 1, and the bottom is going to be x minus 2. In this case, you have the same factor on the top and the bottom. So holes take precedence first. So the hole, there's going to be a hole at x equals 2. And there's nothing else left to set equal to 0 in the denominator, so there's not a vertical asymptote. So what this graph looks like is, if it's a hole at 2, there's actually going to be an open dot at 2. At x equals 2. You can trace your function and see that it actually is going, and then it jumps over 2. And then number 3, I'm going to factor out the top, factor out an x, greatest common factor. And so again, this should be y equals. And then again, you have the exact same thing on the top and the bottom. So there's a hole at x equals -3. And there's not a vertical asymptote. So you can have holes, you can have vertical asymptotes, and you can have horizontal asymptotes. So to find horizontal asymptotes, you're going to look at the degrees of the numerator and the denominator. So if the numerator degree is less than the denominator, then there's a horizontal asymptote at y equals 0. So if the degree on the top is less than on the bottom, as x gets closer and closer to infinity, you're going to be dividing by a greater number, so that's why it's going to turn into 0. If the degrees are equal, then you're going to divide the leading term coefficient, and that's going to be your horizontal asymptote. So a horizontal asymptote takes y equals. If the degree on the top is greater than the degree on the bottom, then there's no horizontal asymptote. So this time we're just checking for horizontal asymptotes. We're not doing vertical. So you need to check out the degree. So the degree of this one is 1 and 1. And so I'm going to do look at the coefficients. The coefficients are -2 divided by 1. So that means it's going to be y equals -1. It's going to be my horizontal asymptote. So check out the degrees of the leading coefficients on the numerator and the denominator. Excuse me. So the degree on the top of here is 0, and the degree on the bottom is 1, so it's greater on the bottom. So remember, if the degree is greater on the bottom, then the asymptote is going to be y equals 0. And then number 3, the degree on the top is 1, degree on the bottom is 1. The coefficients are 1 divided by 1, so it's y equals 1. Number 4, the degree is greater on the bottom. So if it's greater on the bottom, it's going to be y equals 0. And then over here, these 2 degrees are the same, so you're going to do the ratio of the coefficients. So it's y equals 5, 6. And number 6, I have degree 5 on the top, 1 on the bottom. So the degree is higher on the numerator, or greater than the numerator, so there's no vertical asymptote. Or no horizontal asymptote. So make sure you look over this table. And then to graph one of these rational functions, you want to find the x-intercepts and the y-intercept. Excuse me. So to find the x-intercept, you're going to set y equal to 0. So 0 equals x minus 2 over x plus 2, x minus 2. So normally what I'd want to do is I would just want to, this whole expression is equal to 0 on the right hand side if the numerator is equal to 0. So I set the numerator equal to 0 and I get x is 2. So it would seem that the x-intercept is at 2, 0. However, you actually have a hole right here. There's a hole at x equals 2. So it can't be. So what's going to happen is there's no x-intercept. So this function has a hole at 2, so can't be, it's not the x-intercept. The y-intercept, what you're going to do is always set x equal to 0. So if you plug in 0 for x, you're going to get negative 2 over 2 times negative 2. So this is going to be positive 1/2. So the y-intercept is at 0, 1/2. So number 2, so remember to find the x-intercept, set y equal to 0. And you really just need to check the numerator. If you set the numerator equal to 0, then the whole expression is 0. So first I'm going to look how this factors. So this factors into x minus 1, x plus 1. So I know I couldn't have an x-intercept at 1 or negative 1 because it's undefined right here. So there's a vertical asymptote at x equals 1 and a vertical asymptote at x equals negative 1. So then what I'm going to do is I'm going to set the numerator equal to 0. So x has to be 5. So the x-intercept is at 5, 0. And then what I do for the y-intercept is I plug in 0 for x. So it's going to be 5 minus 0 over 0 minus 1. So the y-intercept is at 0, negative 5. And then number 3, there's not a hole, and there's a vertical asymptote at negative 3, and x equals 4. So to find the x-intercept, I set y equal to 0. So x has to be negative 2, so there's at negative 2, 0. There's the x-intercept, and then the y-intercept, I set x equal to 0. So 2 over negative 12 is negative 1/6. So graph the functions include holes, vertical asymptotes, horizontal asymptotes, and x and y intercepts. Okay, so first let's see if we can factor this to figure out our holes. And we can't factor it, so my vertical asymptote is going to be at x equals 1. So I can already kind of graph. This is not going to be a straight line. Okay, so I can already graph my vertical asymptote at x equals 1. Then my horizontal asymptote. So I had the whole vertical asymptote. My horizontal asymptote is going to be, you need to look at the degrees. So the degree of this is 1, the degree of this is 1. So I'm going to do the ratio of the coefficients. So the horizontal asymptote is y equals 1. So I'm going to do a horizontal line like this. Okay, so I have my asymptotes in. And then I'm going to find my x-intercept. So my x-intercept, put y equals 0. So it's going to be -2. So my x-intercept is -2, 0. And my y-intercept is going to be set x equal to 0. So 0 plus 2 over 0 minus 1 is -0, -2. So I'm going to zoom in a little bit. So I do -2, 0 right here, and then 0, -2. Okay, so I'm not quite sure how to do, looks like I have one branch of the graph, so I'm going to plug in, let's plug in another value. You can always make a table of values. I encourage you to make a table of values. So if I plug in 3, what's y going to be? So plug in 3, so it's going to be 3 plus 2, which is 5, divided by 2. So this is 2.5. So it looks like we're branching off in the other part over here. So I go 3, 2.5, and then I'm going to plug in some more. So I graph some more, and what this function is going to look like once I connect the dots is, remember the asymptote cannot cross the blue part. Oops, I didn't even hit any of them. But you have two branches like that. So what you want to do first is factor. Look for a hole. So you're going to have literally a hole at x equals 0. And you're going to have a vertical asymptote at x equals 6. Right here. And then your horizontal asymptote is going to be degree 1, degree 2. Degree is greater on the bottom, so it's going to be y equals 0. So I'm going to sketch this here, there, and then y equals 0. My asymptote is a horizontal line. X equals 6. 1, 2, 3, 4. 2, 3, 4, 5, 6 right here. Oops. Now I'm going to pick values. I want to pick values to the right of 6 right here to see what's going on. I think what's going on is going to be in this over here. But okay, so I sketched and I drew some and I connected them. I made a table and I connected. So if there is a hole, what you need to do is you need to actually draw an open circle at 0. So right here, draw an open circle. And you can erase, oops, I can erase what I already had. So you want to make sure to actually include the hole. So I'm going to link up, I don't have enough time to do this last one on this video, but I'm going to link up how to graph more rational functions. So you start with the hole, then do the vertical asymptote, horizontal asymptote, and then you can find the x and the y-intercept, which I could have added on my table.